Hi everyone and welcome to another session of IGCSE Math Theories. My name is Irfan and today I'm going to teach you about indices and one of its usage, which is writing a number in standard form or also known as scientific form. So what is an index? Well, by now you should know that you don't really need to, if you want to multiply a number more than one time by itself, well, you don't need to write it each time. There is a shortcut to represent this. Basically, if you in example 1, we're multiplying 2 6 times by itself. So I can write 2 and use the power 6. So basically, the 6, we call it the index. Index is nothing but the power to which a number is raised. So in example 2, we have 3 raised to the power of 4, and lastly 7 to the power of 2. So the index respectively would be 4 and 2 for the last example. And the plural for index is indices. So the most important thing about this topic is the laws of indices. So they're not much. There are basically 3 of them, and you need to learn and master all of them if you want to score well in IGCSE exam. So let's start with first law, which says basically if you multiplying two numbers by each other which have the same basically same base but different indices, or it doesn't have to be different necessarily, they could be the same. So all you need to do is just write the base and add the powers together. So an example would be 2. This is the example, 2 to the power of 3 times 2 to the power of 4. So all I need to do right now is to write number 2 and then add the powers, right? The second law says it's about division. So if we have two numbers and if you're dividing by each other and the bases are same, so let me write you down the other version, which is a fraction. So these two represent the same thing basically. So you write the base, but this time you subtract the powers or indices from each other. And an example would be 7 to the power of 5 divided by 7 to the power of 2. So the answer is 7 raised to the power of 3. And the last law is when you have already raised a number to a certain power, like m, and then again you raise it to another power, okay? So in that case, you write the base and you multiply these two numbers basically. So the new index is mn. And take a note that this is different from a raised to the power of m, and m itself is raised to another power. These two are completely different, okay? Because here we raise a to the power of m, the whole thing. That's why I wrote this bracket right here. We raise the whole thing to a new power. So let me give you an example. Let's say we have 2, which is raised to the power of 2 already, and then you raise the whole thing to the power of 3. So the answer is 2 to the power of 6. A common mistake that the students make is that they write 2 to the power of 5. They add these two. So I must tell you that this is different from the first law, okay? And the thing that I just mentioned right here, this is different from, it's not equal to 2 to the power of 2 And these 2 right here, let's say it's raised to the power of 3. So 2 to the power of 3 is 8, right? When you multiply 3 times by itself, it's basically you get 8, and the final answer is 2 raised to the power of 8. And you see these two are not the same. So take a note, but don't worry, you won't come across something like this in IGCSE Math, but I just thought it worth to mention since we are at it right here, but you might see it in additional math. Now, let's get to some more serious examples, combining all these 3 perhaps. So let's say we have 5 raised to the power of 5, then the whole thing is raised to the power of 2 or squared, right? And 4 to the power of 4, the whole thing is cubed, divided by 5 to the power of 8 times 5 to the power of 9. So we've been asked to simplify this. So simplifying, well, what you can do, well, let's apply the third law, if you recall the third law, and get rid of these brackets. So I'm gonna get 5 to the power of 10. Yeah, and here you get 4 to the power of 12, right? You have to multiply them, guys. Don't add them up, that would be wrong. And of course, now the base is different, right? We have 4 here, we have 5. I can't combine them. And in the denominator, I have 5 raised to the power of 8 and 4 raised to the power of 9. Now, you can, since this is a single fraction, and we have the base 5, both in numerator and denominator, you can take a look at these two and these two separately, okay? And I can apply the second law, which was division. So the final answer is 5. 10 minus 8, that would be 2 times 4, 12 minus 9, which gives me 3. And that's the final answer, right? Because they ask us to simplify. Even if you want to go further and rewrite 4 as 2 to the power of 2. So let's leave 5 to the power of 2 there and basically write 4 as 2 to the power of 2, but you have to put it in a bracket, right? And don't forget this index 3, so that we could even simplify it further to 2 to the power of 6. This is also acceptable. This is also okay because we stick to the original numbers. So let me do another one for you very quickly. We have, this is also the matter of simplification. 6 to the power of 3, 4 to the power of 9, divided by 6 to the power of 8 times 4 to the power of 8. I think you know what I'm going to do first. I'm going to multiply these two numbers to give me 6 to the power of 12. And then this is 6 to the power of 3. Maybe I can add them up together in one shot. So that would be 12 and 3, 15. So that takes care of the 6 in the numerator, 4 to the power of 9, 6 to the power of 8, 4 to the power of 8. And now I just have to apply the division, which gives me 6 to the power of this minus that, 7, and 4 to the power of 1, which if the index of a number is 1, guys, we don't write it. Anything to the power of 1 is itself, right? Anything to the power of 1 is itself. So that's it. And again, if you want to expand it, like, I'm sorry, simplify it further, split this 6 to 2 and 3, right? But don't forget the index belongs to both. And also rewrite 4 as 2 to the power of 2. The final answer would be 2 to the power of 9 times 3 to the power of 7. This is not necessarily, guys. I mean, the answer, this is sufficient. for the example above here, this is also, but it's just as a practice that you basically rewrite everything. We go all the way down until we reach a prime number. So that's a good practice. Same thing here. All right, so then we get to zero index and negative index. What does that mean? You might already know when a number is raised to the power of zero, doesn't matter what it is, the answer is always one. I can derive it using those three laws that I have introduced to you earlier. Well, it's very simple. If you recall, the law was that if we divide two numbers with the same base, you just have to subtract the powers. But what would happen if they have the same power, meaning which a m divided by a raised to the power of m? So the answer would be a to the power of, so m minus m, that would be 0, right? And on the left-hand side, we also know that a to the power of m divided by a to the power of m is 1, right? Anything divided by itself is 1. So the conclusion from these two statements is that anything raised to the power of 0 is 1. You don't need to learn how to derive it, guys, but definitely you need to know the fact that anything raised to the power of 0 is 1. We're going to use it in the future. Also, the negative index says that if you have a number with negative index, you can actually bring it down to the denominator, but change the index, basically the sign of the index from negative to positive, or vice versa. If you have a number with positive index and for whatever reason you want to bring it down to the denominator, don't forget to change the sign to negative. So both of these statements, they imply the same thing. Now, how do we derive it? Well, let's start with a raised to the power of negative m itself. I can rewrite this as a to the power of 0 minus m, right? That doesn't harm anyone, right? That is a correct statement. And again, from the law which we have learned earlier, if this is a subtraction, then we know we're dividing two numbers by each other. And what are those numbers? A to the power of 0 divided by a to the power of m, right? So the law was saying that if you have division, then you subtract the powers, but you should know how to apply it both ways. And then from here, the numerator becomes 1 because of this law up here. Anything to the power of 0 is 1. And then I'm left with a to the power of m in the denominator. So that's the conclusion. Let's use these two statements or these two laws in some examples before we go to the next topic, which is standard form. So take a look at this example. 36 times 6 to the power of negative 3, and we've been told to answer these questions without using a calculator, right? So what do you think it would be? Maybe you can pause the video and try to answer this yourself. Well, 36 is a famous number. I hope you have listened to my advice before and memorized the squares of all the digits from 1 to 10. 36 is nothing but 6 to the power of 2, and we have 6 to the power of negative 3. Well, you don't need to bring this down. This is multiplication, and since the bases are same, so what you can do is just add the indices, which gives us 2 plus minus 3, or 2 minus 3, it's the same thing. The answer is 6 to the power of negative 1, which is 1 over 6, right? So that's the final answer without using a calculator. Here, what I'm going to do, the base in the denominator is 2. However, here I have the number 4. So what I can do, I can rewrite 4 as 2 to the power of 2, right? And I leave the denominator untouched. And then this is the matter of division. I have 2 minus 3, right? You have to subtract the power in the denominator from the numerator, and the answer would be minus minus is plus, 2 plus 3 is 5, and 2 raised to the power of 5 is 32, right? Without using a calculator. Now here, anything to the power of 0 is 1. So you can either say, okay, this guy right here is 1, and 1 to the power of anything, guys, 1 to the power of anything is 1, right? So 1 to the power of 2 is 1. Or what you can do also, you can say, you multiply these two, you get 4 to the power of 0, and anything to the power of 0 is 1. So there are two ways you can approach this, but at the end you get 1, and I think that's absolutely obvious. Maybe we can do a more challenging question without calculator. So this might be a little bit difficult. How can we solve this without calculator? So you bring, what you can do, you bring this up in the numerator and the index become positive, and you have 9 times 25, and you should be able to do this mentally. I mean, 10 times 25 is already 250, and this is 9, so it means it should be 25 units less than this is 225, or you can do it directly the normal way you do multiplication, but you should be able to do multiplication of these types, guys, as IGCSE students in your mind mentally. So please practice that. And that brings us to standard form, or the scientific form. Let me write a couple of numbers on the board and then ask you what's the difference between these numbers. So we have 3.2 times 10 to the power of 4, and then we have 3.32, sorry, 32 times 10 to the power of 3, and then we have 32,000, and then we have 320 times 10 to the power of 2, or we have 0.32 times 10 to the power of 5. So if you examine these numbers, you realize that they actually represent the same thing, and that would be 32,000, right? All of them, if you expand them, you get 32,000. But my question is, which one is in standard form? So there is a specific form for any number. There's a specific procedure. If you want to write any number in standard form, it should take the form of this 8 times 10 to the power of n, which this power, it could be positive or negative integer, right? And the a itself, this is the most important part, it should be anything between 1, including 1, all the way to 10, but not 10 itself. So having said that, let's get back here and see which one of them match this description. We have only 3.2, the first one. So the winner is this guy right here. This is in standard form. Now, the thing is, they don't give you a bunch of number in the exam and ask you which one is in standard form. They give you a number and they ask you to rewrite it in standard form. So what you should do is that you have to play around with this position point. Sometimes you have to bring it right or left, and corresponding to that, you play around with the index of 10. Take a look at this example. We have number 72,000, okay? And they ask us to write it in standard form. So what I need to do is to find my A first. And I need, meaning which I need to put a position point here. Okay, so I know it should be 7.2 times 10 to the power of something, right? But what should that index be? Because I put the position point here to compensate that. Now I have to multiply by 10 to the power of 4 or 10,000, right? Because then I have to push this 4 position forward. So that means the index of this 10 here would be 4. And sometimes you have to push it backwards in some cases, and that would be a negative index. We're going to do a couple of examples of those, but let's do the positive indices first. And now we have something like 500 times 30,000. So if they ask you to find the answer in standard form, you have to do the multiplication and then worry about the standard form. The answer would be basically 15 with 6 zeros in front of it, and that is 15 million, right? So I need to put the position point between 1 and 5 because 1.5 is between 1 and 10, right? So once you find the A, then worry about the 10. If the position point is here now, then I have to move it forward. How many position? That would be 7, right? So that would be plus 7 up here. And sometimes they give you a combination, for example, addition or subtraction of two numbers which is already in standard form, and they ask you to do it without using calculator. For example, 3.8 times 10 to the power of 6, then the answer you add it up with 8.7 times 10 to the power of 4. So the thing here is the powers are not the same. However, if you make the powers the same, then you can simply add the numerical value together. Maybe it's better I give you an example of that first, which you don't need to worry about the powers. Take a look at this example. We have 2.4 times 10 to the power of 3 minus 1.2 times 10 to the power of 3. So what you need to do, since the powers are same, right, then you just subtract these two numbers from each other and you get 1.2 times 10 to the power of 3, right? So you basically don't worry about these powers. However, if it's not the same in this case, the first thing you need to do is to make the indices the same. So you have to change them, either change this to 6 or change this to 4. I'm gonna do both so you would see how it works. Okay, so I'm gonna copy down the question here as well. Now, what I'm going to do, I'm going to change this 6 to 4. If you do that, so basically you rewrite this as 10 to the power of 4, right? And then times 10 to the power of 2. So 10 to the power of 2. So you keep this 10 to the power of 4, but that 10 to the power of 2, which is 100, you multiply it by 3.8, which gives you 380, right? Since the index is 2, you push this decimal point 2 position forwards, right? And that's that's the final answer. And then we have plus 8.7 times 10 to the power of 4. Now as you can see, the powers of 10 are the same, so we don't need to worry about that. We just write it here. And what you need to do is to add these two numbers together. The final answer is 388.7. So in the second one, same question, but I'm gonna change this 4 to 6. If you basically I have to multiply it by, let me use another color. If you want to change this to 6, it means you have to multiply this whole thing by 10 to the power of 2. But to compensate that, you divide by 10 to the power of 2 as well, or divide by 100. And this guy, if it's divided by 100, it becomes 0.087. Basically, this decimal point must move 2 positions to the left, right? Because you need to compensate that. And then we have times 10 to the power of 6. So we have taken care of this. And the first one, you can write it the same. You just copy it down. And the final answer would be, since these are same, we add the numerical value, which gives me 3.887. Now, these two numbers, they're exactly the same, guys. This guy right here and this guy right here. So either one is correct, and you have answered the question. So let's move on to negative indices. Basically, when we're dealing with very, very small numbers. For example, the particle physicists, they're dealing with very, very small numbers like the radius of an atom or a nucleus, right? Or the mass of an electron, and etc. So basically, the numbers they're gonna come up with is something like 1.5 times 10 to the power of negative 13. So the index is negative now. You know that if the index is negative, you have to push this decimal point to the left. So this is a very, very small number, but maybe I can give you another example like -5. So if I want to, this is already in the standard form, guys. This is 1.3, but if I want to show you the original number itself, I have to push this decimal point 5 position backward. So the final answer would be 0.000. There is one more 0 and then 1, 3, right? Originally, the position point was here, and then I pushed it 5 position backward to here. So that's what this -5 means, right? However, what if it's like 253 times 10 to the power of a -3, and they're asking us to write it in standard form, right? What do I need to do here? Well, the position point is here, right, in front of 3, and I need to push it back 2 positions, right? And if you do that, if you're going backwards, what do you think we should do? Well, let me write 2.53. I suggest you to pause the video and try to figure out what's the index of 10, right? If it confuses you to do everything in one shot, so I suggest you to, so later on you will master it. So leave this 10 to the power of -3 here and put your focus only on 253. So if you push the position point 2 position backward, to compensate that, you have to multiply it by 10 to the power of 2. You have to multiply it by 100, right? Because this is 253. And let me rewrite 100 as 10 to the power of 2. And then now you can worry about these two guys. The final answer would be 10 to the power of -1. And that is the standard form. So if you come across cases like these, guys, at first, since you're a beginner, I suggest you to simplify it for yourself. You don't need to do everything in one shot. If the number already has a multiple of 10, you can do it in 2 steps rather than everything in 1 step. All right. So let's do another example. 3.2 times 10 to the power of -7. It's the same thing as the first example up there. So they want you to basically write, I'm sorry, there are more than one number. They're asking you to write it in the order of magnitude. So this is an interesting question. So we have this, we have 6.8 times 10 to the power of 5. We have 6.74 times 10 to the power of -4. We have 8.4 times 10 to the power of 2. There's a 1 here missing. I think it's very clear at first glance. The question is not really tricky, guys, because everything is given in standard form. They could have made it more difficult if it wasn't in standard form. So if it's in standard form, all you need to care about is basically the powers. The bigger the power, the bigger the number. So definitely this guy is the largest one, that's number 1. And this guy is number 2 because the index is +2. This is definitely the third, and this is the fourth. So again, I repeat, this question was quite easy because everything was in standard form. If it wasn't in standard form, it wasn't given in standard form, I suggest you to convert everything in standard form first and then compare the powers separately. Now, having said that, it brings us to the last topic, which is a very important topic regarding indices, and that's exponential equation. So I have to define to you what an exponential equation is. Basically, if the unknown or the variable that you're looking for is in the power or it's the index, then we have ourselves an exponential equations. Take a look at this equation. 2 raised to the power of x is equal to 32. So if this x was in front of 2, something like this, 2x equals to 32, this is a very easy linear equation, right? And the answer, of course, would be you divide both sides by 2 and x is found to be 16, right? So that's the equation that so far you have been dealing with. However, this is an exponential equation. Now, what you need to do, the goal is to manipulate both sides, in this case only one side, to reach the same base on both sides. So right now, 2, this is a prime number, right? And you cannot simplify this further. However, 32 can be rewritten as the product of prime numbers. And actually, that's a famous number, which I told you to memorize, right? 2 to the power of 5. Do you still recall? 32 is 2 to the power of 5. However, if you don't know the answer directly, don't worry. You don't panic, because from topic 1, I have taught you how to rewrite any number in the product of its prime number. So basically, this is the technique. You start dividing, you start with the smallest prime number, which is 2. The answer is 16. Again, it is divisible by 2, so we continue one more time, another time, and lastly, you get 1. So 32 is 2 raised to the power of 5. Okay, and if we know that, then I can write the left hand side and the right hand side is 2 to the power of 5. So when you reach this stage where the bases on both sides are the same, so you can conclude that the powers must be the same as well. So the answer is x equals to 5. Now, For your level, they don't give you anything that the bases might end up being different. But for those students who are taking additional math, you might end up with 2 on the left and 3 on the right. Still, you can solve it using logarithm, but that's not included in IGCSE math syllabus. So let me do another one. Let's say we have 3. Let's change the variable to n perhaps. We have n minus 2 is equal to 81. Now 81 is a famous number. I know that it's already 3 to the power of 4. However, if you don't know that, again, don't worry. You can always use this technique to rewrite 81 as a product of prime numbers. It is divisible by 3. Basically, or you can say 81 is 9 by 9, right? And that is 3 to the power of 4. But still, if you don't want to use that, you can divide that by 3. You get 27. 3 one more time, 9. Divide by 3. That gives us 3 again. Divide by 3. That gives us 1. So that's the idea. That's how you rewrite any number in the product of prime numbers. So now the right hand side I know is 3 to the power of 4. So I have reached this stage where the bases are the same. So the conclusion is the powers must be the same as well, meaning which n minus 2 must be equal to 4, and that yields to n being 6, right? So as simple as that. Let me do 2 more before we get to the fractional exponential. So 1 over 16, this is a good example, 1 over 16 raised to the power of n is equal to 4. And another example, 3 raised to the power of negative x plus 1, the whole thing is in the bracket, equals to 1 over 81. Now, you don't need to convert 4 to 2 to the power of 2 and 16 to 2 to the power of 4. All you need to do is to convert 16 to 4, guys, right? We have 4 here. Just convert it to something that has 4 in it. And 16 is a famous number. That's a square number. So that's 4 to the power of 2, or 4 square. So if you do that, we get 1 over 4 squared raised to the power of n equals to 4, right? That's the first thing. Then what you can do, you can bring this guy up in the numerator by changing the sign of its index, right? So meaning which, continue here, you can write 4 raised to the power of negative 2, then raised to the power of n. That's the law which I have told you. This was the law. You can bring it down or bring it up, just convert the sign. So if it's negative, you can also bring it down, just convert. So this is the law. It's the same thing. And then the right hand side is 4. So the left hand side, I have to multiply these two. That was the third law that I taught you guys. And the answer is 4. Now I have reached the stage where on both sides the bases are same, so the powers must be the same. So here when we don't put the power, it means the index is 1. So the answer is negative 2n must be 1. Therefore, n is negative half, right? N is negative half. Now, you could have started differently, but at the end, you should get the same answer. And what I mean by that, you could have said, because there is a law that, guys, says if you have a multiplication or even division, and then the whole thing is raised to a power, that power belongs to every term, right, inside the bracket. I have already mentioned this for multiplication, but it's true for division as well. You could have done this as well. So meaning which, you start by saying this is 1 to the power of n. However, 1 to the power of anything is 1 itself, and this is 16 to the power of n. And then bring 16 to the power of n to the numerator, and you get 16 raised to the power of negative n must be 4, and then 16 is 4 to the power of 2. That 2 is multiplied by negative n, so you get negative 2n, and on the right hand side is 4. So it's basically this stage, same as this stage. So how you start, usually there are a few ways. So I don't want to limit you to using only one way. It's like solving a puzzle. So it takes practice, guys, for you to see which method you prefer. Here, the left hand side is 3. So you don't really, if you have a base which is a prime number, so leave it there because there is nothing you can do there, okay? It's as simple as it can be. However, 81, we have it right here, right? I haven't erased it yet. That's 3 to the power of 4, right? But it's in the denominator. You can bring it up if you want. So, but don't forget to change the sign of the index. So this is +1. Okay, and that would be 3 raised to the power of negative 4. So the bases are all these the same. The conclusion is that the powers must be the same. So x would be positive 5, right? Negative x would be negative 5. So the negative cancels out and you left with x equals to be 5. So these are quite easy exponential equations because we haven't touched the fractional indices yet, which is the last topic for today. So what is fractional indices? So anything like 16 raised to power of half, right? As you can see, the power is a fraction. It's not an integer anymore. However, how do we solve this? Well, 16, you can write 16 as 4 raised to the power of 2. But if you do that, this guy is pushed outside and you have to write it here, right? That would be outside the bracket. So it's raised. So basically, the only change I made is rewrite 16 as 4 raised to the power of 2. And then if you use the third law, basically you multiply these two by each other. So the answer is 2 times half is 1. So it's the final answer is 4. So 16 raised to the power of half gives us 4. You know that 16 is a square number. So you know that the square root of 16 also gives us number 4, right? So I'm going to write that. This is 16 should give us 4. The conclusion here you can make is that 16 raised to the power of half is the same as square root of 16, right? Let me give you another example because I'm getting to something, guys. I want to generalize a rule. How about 27 raised to the power of third, 1/3, and that would be 27 is a cube number. You can write it as 3 to the power of 3, and then the same thing, you apply the third rule. 3 times 1/3 gives us 1, so the answer is 3 to the power of 1/3. The cube root of 27 is also 3, right? So the conclusion here I make is that 27 raised to the power of 1/3 is same as cube root of 27 because that gives me the number, both of them gives me the number 3. So I can generalize that any number raised to the power of 1/n is the same as the nth root of that number, right? Can you see here is actually when we say square root, there should be a 2 here, but by convention, we don't really mention that. We don't write that. But the third root, more than the second root, right? We have to write it. So if this is 3, this is 3. However, the generalized format of this says if this is m, this should be m as well, or you can put this m outside, so the nth root of a raised to the power of m. So these two guys are the same. Okay, so you can push this m inside. So this is very, very important law. So since you've just been introduced to it, maybe we can start with some quite easy examples. So in these following examples, we've been asked to find the answer without using a calculator. So 16 raised to the power of quarter, you can write this as the fourth root of 16, right? That's one way. And basically the answer would be 2, because 2, when you multiply it 4 times by itself, or let me, I skip one step. You can write 16 as 2 to the power of 4, and we have the fourth root, and these two guys, they cancel out, because take a look here. I can write square root of 2 to the power of 4. I'm sorry, the fourth root, you can write it as 2, 4 divided by 4, right? 2 raised to the power of 4 over 4, which is 2, if you apply this. So I'm going backwards. You should know both ways. So the final answer is 2, or alternatively, what you can do, you can say 16 raised to the power of 1 over 4. You write 16 as 2 to the power of 4 and leave this guy outside, and then say, according to the third law, these two numbers must be multiplied by each other. So the answer is 1. So we have 2 as the final answer. So this is the second approach. So as you can see, there is not only one approach. As long as you master those laws, you can apply them whenever it's needed. Maybe we do 2 more. 25 raised to the power of 3 over 2, or 1.5. So this is equal to, basically, there are two ways you can approach this. You can either split this fraction and write it as 25 raised to the power of half, and then times 3, right? This 3 over 2 can be rewritten as half times 3. So we keep the half inside, because that means square root of 25, right? This is 1, and this is 2 outside, but we don't really write it for square root. So, and square root of 5 is, a square root of 25 is 5. 5 raised to the power of 3 is 125. So we can, we don't need to use a calculator. Or what you can do is keep this index 3 over 2. So 25 raised to the power of 3 over 2. So you keep this untouched. So, and you change 25 to 5 to the power of 2, right? And then you put this 3 over 2 outside, and I think the rest is very clear. 2 times 3 over 2. So the 2 cancels, you're left with 5 to the power of 3, which is again 125. So the next two that I'm about to do, I want you to pause the video and try to answer it yourself. So the third one is actually an exponential equation, and the fourth one as well. So I'm gonna solve it for you guys. This is basically 2 to the power of 5, and then raised to the power of x. This is 2. So 5 times x is 5x. The right hand side is 2. The bases are same. The conclusion is that the powers must be same, and x happens to be 1 over 5. So x is basically a fraction. So meaning which 32 raised to the power of 1 over 5 or 1/5 gives us 2, or the fifth root of 32 is 2, right? That's the same thing. But you don't need to, I just wanted to tell you what it means actually. They just ask us to find x, that's all. Same thing here, 125 is 5 to the power of 3 raised to the power of x. This is 5. The left hand side gives us 3x, right hand side 5. The index is 1, of course. The bases are same. The powers must be same on both sides. So the conclusion is x is 1 over 3. And yes, that's it. So maybe I can do a combination of, especially this is very useful, guys, when they ask us to simplify. So, and without a calculator, this is a common question. So I'm going to make it a little bit more complicated this time. We're going to use all the laws that we have learned today. So this is the fraction that they ask us to evaluate without using a calculator. Okay, raised to the power of half. The second one is 5 raised to the power of 1 over 3. The whole thing is raised to the power of half times 5 raised to the power of 5 over 6. As you can see, they gave us all the powers in fraction, which shouldn't be difficult for us. Still, we can apply the rules. Well, I'm going to take care of these two guys right here. You can multiply it. You remember the third law. So the answer would be 4. 2 times negative 1 over 4 is negative half, right? And leave the 9. However, you can rewrite 9 as 3 to the power of 2, and then raise the whole thing to 3 over 2. So this is the first thing I do in the numerator. In the denominator, what I'm going to do is just change 1 over 4 to 4 to the power of negative 1, right? 1 over 4 is equal to 4 raised to the power of negative 1, because the index is 1 in the numerator, in the denominator. You bring it up and it becomes negatives. So after this, everything should be clear. Why? Because first of all, this 2 is gone, right? And when you perform the multiplication, you have 3 to the power of 3. And for this part, which is division, basically you can apply the second law, which was saying if the bases are same, you subtract the powers, meaning which negative half minus 1. Please don't mess up with the signs. And this whole thing times 3 to the power of 3, right? And then this guy right here is negative half plus 1, which is plus half. So 4 raised to the power of half, which is the same thing as square root of 4, right? These two are the same, times 3 to the power of 3. So the square root of 4 is 2. 3 to the power of 3 is 27. And the answer is 54. As simple as that. You can solve it without using a calculator. So by now you should have done the second one. Maybe you can pause the video and try it yourself. What I'm gonna do again, I'm gonna take care of these two guys first. The answer would be 5 raised to the power of 1 over 6 times 5 raised to the power of 5 over 6. And this is 4 negative half. Well, you can, or maybe I bring the whole thing up times this guy. I'm going to bring it up. It becomes 4 raised to the power of positive half, right? So these two together, they can unite and become 5. 1 over 6 plus 5 over 6 is 6 over 6, right? Or basically 1. right? So this is 5 and times, this is again 4 raised to the power of half is square root of 4, which is 2. So I'm left with 2 times 5, which is 10. The answer is 10. Maybe I do one more example and then we're done. 27 raised to the power of 2 over 3 times 3 to the power of negative 3, 9. We have in the denominator 9 raised to the power of negative half. So, okay, I can convert everything. All of them are powers of 3, right? Can you see that? Those are famous numbers. Well, there are a few ways you can start, but I'm going to rewrite 27 as 3 to the power of 3 and then raise it to 2/3. This is 3 to the power of negative 3. This guy right here, I'm going to bring it up and it becomes 9 to the power of positive half. So the first term simplifies to 3 to the power of 2. This guy is 3 to the power of negative 3. And this guy is 3 because 9 raised to the power of half is square root of 9, which is 3. And now the index of that is 1. So the bases are same. All I need to do is to add the indices 2 and 1, 3 with negative 3, 0. And anything raised to the power of 0 is 1. I think we're done with this topic. Thank you for watching the videos and stay safe. See you in the future videos. Thank you, guys.